Today we're going to review solving equations and inequalities, so a little algebra review to start us off for the year. The first section is solving equations, and we've been solving equations for several years now. If we look at this equation, we have a 5x on one side and a 4x on the other side, and then we have two constant terms. So the first thing we need to do is to add the opposite, to move all of your variable terms to one side. 5x plus negative 4x gives you 1x plus 5 is equal to 2, and then we do the same thing with the constant term, and we end up with x is equal to negative 3. You can always check your solution by substituting it back in. So if you want to check, it's 5 times negative 3 plus 5, and that should be equal to 4 times negative 3 plus 2. Negative 15 plus 5, negative 12 plus 2, we've got negative 10 is equal to negative 10, so we are good. The next type of equation is a simple one, but I show it because a lot of times kids get a little messed up when you see this when you see the variable over a number. Here's what I recommend. You rewrite it because there's an implied 1 coefficient in front of the x. So to rewrite this, it would be negative 1/4 times x is equal to 5. When you have a fractional coefficient, we're going to multiply by the reciprocal to eliminate that negative 1/4. So here's what it looks like. Negative 4 over 1 on both sides. And then to that you're going to multiply the negative 1/4 times x and by the 5 over 1. And so what happens is these reduce, and you end up with x is equal to negative 4 times 5 is negative 20. Again, you can always check by substituting back in. If I put in negative 20 divided by 4, we want to know if that's equal to 5, except I have an additional negative here, so we do have to be careful. So it's really negative 1 times negative 20 when you substitute it back in, and you end up with 5 is equal to 5, and that checks out. The next type of equation we're going to deal with is solving with multiple variables. So in this equation I have a p is equal to 2 times the quantity 3 plus a plus 5 plus a 4 on the end. I want to solve that for a. I have to tell you which variable that we are solving for when there is more than one. So to get started with this, if I write it again here, p is equal to 2 times 3 plus, this is my variable. You can circle it on your paper, you can underline it, whatever you need to do so you know which one you are solving for. To do this, I'm going to think of my order of operations. I'm going to combine the 3 and the 5, and then I'm going to distribute the 2 inside the parentheses. So the p is going to stay p, and there's my 2, and I have a plus 8 plus 4. When I distribute, I am only distributing into the parentheses. I am not multiplying the 2 by the 4. So p is 2a plus 16 plus 4. Now I'm going to combine these two. P is equal to 2a plus 20. And again, a is my variable, so I want to solve for a. The next step would be to subtract away the constant term, which is the 20. And if I move over here, I end up with p minus 20 is equal to 2a. The final thing to do is to get rid of the coefficient, and I'm going to do that by dividing away the 2, which means I divide away on the other side. And you can leave it as that fraction. P minus 20 over 2 is equal to a. And that is your answer solved in terms of a, meaning a is by itself. So that was basic equation solving. Now we're going to talk about ratios and proportions. And so we want to define what a ratio is and what a proportion is, and we don't want to get them mixed up. So a ratio is a quotient that compares two quantities. And usually it can be represented by a colon, so 3 to 2, or 3 to 2, or 3 over 2. Those all represent the same ratio. So a ratio is just something that compares two quantities, and it can actually compare, a continuous ratio can compare more than two. For right now, we're just going to review the comparing the two quantities. A proportion is an equation. It states that two ratios are equal. So an example of a proportion would be 3 over 2 is equal to x over 4. And we use cross multiplication to solve a proportion because we actually have terminology for these things. The lower left, upper right are called the means. The upper left, lower right are called the extremes, and the product of the means is always equal to the product of the extremes in a proportion. So if you were to cross multiply, you would get something like 2x is equal to 12, and then you could solve it from there. So that's the difference between a ratio and a proportion. A ratio is a comparison, and a proportion is an equation. So here's an example of how we solve a ratio by using a proportion. Here's our ratio. There are 3 hamburgers served for every 2 tacos served at a restaurant. So we can write our proportion. There are 3 hamburgers for every 2 tacos served. If 21 hamburgers are served, how many tacos are served? So we're going to solve for tacos, right? We want to let x be equal to tacos. And we know how many hamburgers are served. Well, the 3 goes with the hamburgers, and the 2 goes with the tacos. So we just set it up. 3 to 2 is equal to 21 over x. And then you cross multiply. 3 times x is 42. So x is going to end up being, let's see, it's going to be 14. X is 14. So there are 14 tacos. Finally, we're going to do a quick review of inequalities and solving inequalities. Inequalities are solved like equations, only if you have to multiply or divide by a negative, you're going to change the sign. This sign is less than. If I look at my problems, I don't have any, I'm not going to be multiplying or dividing by a negative symbol here, so the sign's going to stay the way it is. To do this, then, we just solve like a regular equation. We're going to add the inverse to get my variable by itself. I have x over 8 is less than 1. And again, there's an implied 1 in the numerator here, so I'm going to rewrite that as 1 over 8 times x is less than 1. We're going to multiply by the reciprocal, which is 8 over 1. And since that's positive, I don't have to change the sign. I just have x is less than 8. If you solve it, and any value less than 8 is going to produce a fraction less than 1 here. When you add that to 8, that will always be less than 9. We can graph this solution on a number line. I have 0 as a reference point. I have the other value that's involved. It's an open circle, and it's going to be shaded to the left. In interval notation, I'm going to end at 8, not including 8, and I'm going to extend to negative infinity. So that's how you solve an inequality and represent the solution in graphing and in interval notation. Finally, we're going to look at one verbal problem. Write and solve the inequality. The sum of y and 20 is less than 37. So this is an inequality. Sometimes less than represents subtraction, but in this case, when you see the is here, we have to understand that is less than. This is all taking place of replacing the equal sign, so it is an inequality. If there were an additional word here, like is 5 less than 37, then it would not be an inequality. But since it just says is less than, that is your inequality. So the sum is addition of y and 20. Y plus 20. There's the sum of y plus 20 is less than 37. And then it's a pretty simple thing to solve. You subtract 20 from both sides, and y is less than 17. There's your solution. On a number line, you would have 0 as a reference point and the number 17, open circle, shaded to the left. In interval notation, you would start at negative infinity and come up to 17, and you don't include it. If it were less than or equal to, then you would include it, but since it's not, you don't. And that is a review of basic equation and inequality solving to get us started for the year.